Okay, good evening, everybody. I prefer to give you the lecture of general steel structure again to show you how do I draw the plan, the typical elevation, the end gables, and the side view. Now, in this lecture, I will give you two lectures. In this lecture, I will be explaining the plan of the roof and the mezzanine floor, the typical, the lower wind bracing, and the typical elevation and the end gable. And there will be another lecture where I will explain the side view of the bracing and the cladding. Okay, let us imagine that we have, this is very close to what you have, by the way, in your homework assignment, and this will be project number 2, the first part of it, which is the general layout of steel structure. We are drawing here the steel elements by single line, but we need to understand these elements, what they are and how they are arranged and how do we draw them. Now imagine that we are having a piece of land like this. This is the built-up area. It is divided into, for example, administrative part and exhibition part. So here I'm having exhibition and here I'm having administration. It is required not to have any columns in the middle, in this part and in this part. Only columns are allowed at the outer perimeter and in between the two holes. So how are we going to arrange our main system? If we arrange the main system in this direction, like this, we're allowed to have a column here and a column here and a column there. So the maximum span is 24 meters. So the bending moment is proportional to 24 square. But if we arrange the main system in this direction, then we are not allowed to have except a column here and a column there. So the span will be 47. The bending moment will be proportional to 47 square. So you will have, in this direction, the bending moment is proportional to 24 square, and in this direction to 47 square. So this means that the bending moment here is 4 times as much as the bending moment in the other direction. طبعا, when the bending moment increases, you will have to increase the depth of the section and the steel will be heavier and more expensive. يبقى the logical direction of the main system to be in the shorter direction. Now I will locate the columns. I will start locating the columns like this. See, when we draw the columns, the steel column is an I-shaped section. This is the web and this is the flange. We are always locating the main system such that the web is parallel to the direction of the main system itself. Very good. So this system will be repeated like this. I will have a column here, a column here, and a column there. Question: what will be this spacing? Again, if you recall what we explained in our lectures, this spacing should be from 4 to 7 meters. Why? We don't want this distance to be so narrow so that the columns will be close to each other. You are having so many systems, okay, to allow for any kind of door opening or accessibility to the hole from the side. يبقى the minimum is 4. And we don't prefer to exceed more than 7. Why? Because when this distance increases, we are going to cover this with a beam in this direction. يبقى the span of the beam will be larger. When the span of the beam increases, the cross section of the beam increases, it gets heavier, and of course this will put more load on the main system, so the system will be more expensive. يبقى it is better to be limited from 4 to 7. The preferable number is 6. Why? Because the length of the secondary beam of these beams, of any steel beam in the factory, is 12 meters. All what I need to do is to cut the beam into 2 pieces, so I will put here 1 piece and then another piece next to it. We don't have waste. But if this distance is 7, I need to cut 7 meters, there will remain 5 meters from the 12, then I need to splice it or weld it with another 2 meters to form another beam. يبقى we are reducing the amount of effort. Very good. But he gave us this distance is 47. It is not divisible by 6. What do we do? The majority of the bays will be selected to be 6 meters, and there remains maybe 1 or 2 bays different. No problem. So we can think of the 47. The 47 is 6 by 7, which is 42, plus 5. This means that I will have one bay to be 5 meter and the rest of the bays to be 6 meters. No problem. Where do we put this 5 meter in coordination with the architect? Always I prefer to make it something arbitrary in the middle. I don't put it the first one or the last one or anything in the middle. If I will divide my hole like that. Okay, I will select this distance. I will put this 6 meters and then 5 meters. You don't need to write every one, but you can say 6 by 6 equals 36 meters. Okay? And we need to draw all of the columns. Such that the web is parallel to the main system, as you can see. Okay, like that. We can give these axes a name. We can name the axes. Whenever we are having a column, we have to put an X. One. Okay. Now, we need to see typical elevation. We need to cut here to see a typical elevation of our main system. So this is the 0 level, and we are having, this is the first axe, this is the second one, and this is the third one. Okay, we have the span here is 12 meters, and this is 24 meters. If you open the notes and ask yourself, if I'm having a span of 12 meters, what is the possible systems that I can use? We can use simple beam, or we can use simple truss, or we can use a frame. And when we have the span 24 meter, what is the possible systems that we can have? We can have a frame, or we can have a column truss frame. In order to show you variety, I am going to select a frame for the 12 meter span and a column truss frame for the 24 meter span. This does not mean that I'm going to repeat this column. It will be a single column that will serve both systems. So one student can imagine that we can have the frame like this and the column truss frame like that. Okay, this is very good, but we are having here a problem. Now, As you learned from the previous lectures that the roof should be sloped by a slope of 1 to 10. In order to drain the water, the water is having a harmful effect on the steel structure. Now the water will drain in this direction and will drain in this direction and also will drain here and will drain there. What will happen in this case? The water will collect at this position. Therefore, we should provide a rain gutter or something that will collect the water, and then it is attached to a pipe, and this pipe or downspout is attached to a chamber where we collect the water, and then we are draining it to the outside of the structure like that. So water will be drained in this direction and then under the ground in that direction. Always this system is not preferable because it is possible that this drainage will be closed somehow due to dust, due to the leaves of the trees or something like that, and water will collect here and will start leaking inside the structure. So we prefer not to have such a thing inside our structure. What will be the option? We can think of something else. We can think of something else. Now, here is our axis, like that. I will have the frame in one direction like this. And this is the rafter of the frame, and this connection is a rigid connection. So this is a perfect frame, okay? And I will go with the same slope because this span is the largest span. I will go with the same slope like this. And I will use here a truss. Instead of having one point in the middle that will collect the water, I used this floor or this roof is having the same slope 1 to 10, and this is having a slope 1 to 10. And this is also 1 to 10. Imagine, or as we learned in the previous lectures, that the slope of the roof of the steel is ranging from 1 to 5 to 1 to 20. The most commonly used is 1 to 10. Okay? So here I am having, this is a frame, and here we are having a column truss frame. The columns are continued, and the truss is connected to the column from the side. Very good. Okay. Now this is 24, so this is 12 and this is 12. We can divide this into 3. So this distance will be 2 meters, will be 4 meters. And we can have our truss like that to be a stable truss. It should be like this type. When we are thinking of the purlins that will cover or that will be supported on this truss, the purlins will have to be located over the joints. This means that the spacing between the purlins will be 4 meters. That's a lot. Because as we said, the spacing between the purlins should be between 2 and 3 meters so that the cladding system is not that thick and is not that heavy. I need to have another purlin in the middle. How can we do that? We have to provide a subdivided system. We have to provide another joint in the middle. Okay? In order to reduce the spacing between the purlins. The purlins will be located like that. And here I'm having the roof cover. Now take care. We are having 2 points here that we need to talk about. If we elaborate, on what is happening here, okay? We are having here the truss members are like that. and we are having one purlin on this side and another purlin on the other side. Okay, and of course we are having purlins like this, and this is the cladding. The purlin are always located over the joint, as you know. Okay, now this sheet and this sheet, it cannot be bent, and this part is void. You can have here dust or rainwater can enter from there. So there should be an accessory that will close this part, as you have seen in our previous lectures, that will close this part. We also understand that whenever we are having change in the slope, this slope is like this and then it changed like this, we should have two purlins, because this purlin will support the sheet on the left and this purlin will support the sheet on the right. Okay, now this part, the spacing here between the purlins is obligatory, and it is 2 meters according to the spacing between the joints of the truss. Type in the other part, for the part of the frame, you are free to select whatever spacing you have, because you like, because there is no restriction where you can put the purlin. You can put the purlin anywhere. We know that the spacing between the purlins is ranging from, as we said, here from 2 to 3 meters. The cover will be sandwich panels, the one that is used to isolate the temperature. And here we can take the spacing between the purlin ranging from 1 to 2, so it is 1.5 مثلا, and we can have the cover corrugated sheet. So in this part it will be covered into 8 equal spaces. The spacing between the purlins is 1.5 meters, and here we are having corrugated sheet, single layer of corrugated sheets. Okay? طيب, we want to draw this on the plan. On the plan we have, this is the main system drawn in blue. We indicated the columns of the main system. We want to draw the purlins now. Let us draw the columns, the purlins in black. So we have the purlins will be drawn like this. And you can write here that this is 1.5 by 8 equals 12. Okay, for the other part, we are having two purlins in the middle, remember, because we are having change in slope. So I have to draw these two purlins first. I have to remind myself that I am having two purlins next to each other in the middle, because there is a slope left and right. Okay? And then this part is divided into 6 parts. And this part is also divided into 6 parts. Very good. We can write here that this is 2 multiplied by 12 equals 24. Let us continue our elevation. This is, for example, section A. So this is here section A. Okay? Now, if this is the 0 level, as we have seen together in the previous lectures, that we have to provide a concrete pedestal. There should be a concrete pedestal, the level of which is higher than the zero level, let us say by 10 centimeter, or it can be flushed with the finished floor level inside. This of course is provided with reinforced concrete footing and plain concrete footing. Okay, we are only interested to show here the concrete pedestal without the details left from that. Okay, now we covered the roof. Okay, we need to cover the sides. Let us have the different heights here. This one, imagine that this height, for example, is 10 meters. And we are having this one. How do we get this part? We are having, this is 12 meters and the slope is 1 to 10, which means that this will be 1.2 meters. Okay? This means that this part is also, from here to there, will be the height of this column is the same as the height of this column. From this point to this point, it is 11.2, so this one also will be 11.2. Okay? Type. For the side cladding, we have seen that we are using brick wall in the lower part. The height of the brick wall ranges from 1 meter up till 3 meters. And after that, we are covering with corrugated sheet. So we are going to fix here the level, this level, up till 3 meters, we are having brick wall. Okay, so this part is 3 meters. There remains from the 10 meter, we are having this part here is 7 meters. We have to put a purlin on this edge and a purlin over the brick wall, and the spacing here is 7 meters. Of course, it is too much for the span of the corrugated sheet. We have to divide the 7 meter such that the spacing between the side purlins is ranging from 1 to 2. We can divide this into 4 equal spaces. So if you divided 7 over 4, it will give us 1.75. This means that you are having here, this is the cladding, and the typical distance here is 1.75 meters. Type. Let me elaborate on what will happen on this edge or in this corner. We are having here, this is our frame. Like this. And we are having a purlin here and another purlin there, and these are the side purlins. We are going to cover this with corrugated sheet and here with corrugated sheet. Again, the corrugated sheet cannot be bent. The water will transfer in between these two elements. I need to close this part. How do we close it? We close it using rain gutter like this. This is called rain gutter. So the water will collect from here and will collect inside the rain gutter, and there will be a pipe that will collect the water every 6 or 12 meters. This is called downspout. This is how we close this corner, and we have seen how to close the apex. This is called the apex, that we should provide an accessory that will close this part like that. Again, here we are having the rain gutter like this, and if you look here, we are having this is 3 meters, and then remains for us this will be 8.2 meters. We can divide this into 5 equal spaces, or we can follow the spaces that we selected here 1.75, so there will remain for us one spacing at the top, it will be 1.2. So on this side, I will take 3 meters. This distance here, from this point to this point will be 8.2. So I will take it 1.75 by 4. And there will remain for us a distance like that. Here I will have, this distance is 1.2 and this is 4 multiplied by 1.75. Of course we are having a purlin here and another purlin there, and we should have the rain gutter provided here like this. يبقى this for us is a complete elevation. This is the 0 level, and the level of the pedestal is 0.1. We studied the side cladding. We are having 3 meters of brick wall over the concrete pedestal, and then after that we are having purlin spaced at distance 1.75. In this part we are having the spacing between the purlin 1.5, and here we are having spacing 2 meters, and again we studied this part. This is a complete section A. So if you want to look to this a little bit, this is one of the answers that we have, which is the typical elevation. It is showing us everything. Also, you have to indicate here, you have to indicate the height of the truss. Usually this value is in the order of 1/10 of the span. So the span is 24 meters. So the height of the truss here, let us say it will be 2 meters. Okay? So this is a correct or a complete typical section A. Section A was here, for example. Very good. What do we have missing here? We have to think of the upper bracing. Let me explain this for you a little bit. I need to erase that. Unfortunately, I don't have much space, but I'm going to erase this. Now imagine that we are having a frame like this. This frame is spaced from the one behind 6 meters. Any wind coming in this direction will be causing a force in the same plane of the frame. So it can be supported by the frame. But any wind in this direction cannot be supported by the frame. Why? Because it is causing out of plane forces like that. It will cause this frame to collapse. That is why we have to use upper wind bracing. Here are our purlins. I need to make a truss between this frame and the one behind. How do I make a truss? For the truss to be stable, it has to be composed of triangles. Therefore, I will take a triangle like that. No problem, and I can continue. But take care. This angle, theta, should be from 30 to 60 degrees. Now we said that the spacing between the purlins, let us say, is 1 to 2 meters, and this distance is 6 meters. When you calculate this angle, how much it would be? It would be something less than 30 degrees. Therefore, it is better not to use the truss this way. We want to select our angles so that it would be exactly or very close to 30 to 60. So I can select every other purlin or every 3 purlins together like that. Now we formed the upper bracing. Very good. When you are having forces applied in the out of plane, it will be taken by this truss. But where is this truss supported? It will transfer the force from the frame in the facade to the frame behind. Again, the frame behind cannot take this force because it is an out of plane force for this frame. That's why I will have to continue the bracing on the side. I will have to continue the bracing on the side like this. This is called the upper wind bracing, and this is called the vertical or transversal wind bracing. If the system that we have, this is if you are having a frame. What if you are having a truss? If you are having here if this was a truss, you are having a member like that, and this will be the truss. Of course, there's another truss behind the other one. In this case, what will happen? In this case, the wind will be applied here as well, at these points, in addition to the points at the top. Who is going to support the wind? I will have to provide upper wind bracing, and I will have to attach from underneath the truss another system, which is the lower bracing. Okay? In this case, whenever we are having a truss, there should be also a lower bracing. The upper bracing is covering or is attached to the top cord of the truss. The lower bracing is attached to the bottom cord. If I am having a frame, of course there is no meaning for the lower bracing, and all what I have is an upper bracing. Whenever you are having a truss like that and there is lower bracing, this means that the force is transferred to this column at this point and this point. Okay? Because these are the 2 points where the upper bracing and the lower bracing is attached to the column. When I'm going to select the system of the transversal bracing, now let me look in this direction like that. Okay, I will see a column and a column. Here at this level we are having the upper wind bracing, and at this level we are having the lower wind bracing. At the upper wind bracing we are having an upper force caused by the wind coming on the facade, and at the level of the lower bracing also we are having another force. So we are having a force here and we are having a force like this. Very good. Now I want to construct a truss in the vertical direction as before, in order to support the reaction caused by the upper wind bracing and the reaction caused by the lower wind bracing. One student will select this configuration as such, and he or she will tell me, I selected this configuration so that the angle, as he told us, to be ranging from 30 to 60 degrees. Now, such an answer, it means that he or she did not study with me 302. Because in the trusses, you cannot have a force applied in the middle of the member. Whenever you are having a force here, we should have also a member in the transversal wind bracing. This should be not possible. I should not do that. And I will have to have a member here and another member there. Now I want to establish the shape of the transversal bracing such that the angle is between 30 and 60 degree. So I will see here the relation between this length and this length. Maybe I can take it in one cross like this, but this length is so narrow compared to the 6 meters or the spacing. So instead of having a cross like that, we can have a K truss. In this case, this angle and this angle is ranging from 30 to 60. Very good. Now I'm looking to the plan and I want to draw the upper wind bracing. Let us see here. You remember that the spacing between the purlins is 1.5 meter and this distance is 6. I want the angle of the bracing to be from 30 to 60 degrees. Of course, preferable to be 45. What if I counted 4 of these spaces? 1, 2, 3, 4. This distance here will be 6 and this is 6. It is better that I can take my cross like this. ليه? Because I want the angle to be from 30 to 60, preferable to be 45 degree. Now I will take another 4, 1, 2, 3, 4. This will be closed exactly like this at an angle 45. Type. This distance here is 2 meters. So I will take every 2, okay, or every 3. If I took every 3, 1, 2, 3, this will give me 6 meters. This will be 6, and this will be 6, like that. No problem, you can take every 3 spaces together in one cross, and also another cross and another cross. Top question. Where would be the vertical bracing? The vertical bracing, as you can see here in this example, as we solved it together, the vertical bracing is established between the 2 columns. I should have vertical bracing here and vertical bracing between the other 2 columns there. I don't have any vertical bracing in the middle. Now I am having a column here and a column there. I should have an indication for a vertical bracing, indication for a vertical bracing, and indication for the vertical bracing. We don't have vertical bracing in the middle because I don't have a column. We are drawing this dotted line to indicate the vertical bracing between the 2 columns. Since I'm having column on this axis and this axis and this axis, this is the location of the vertical bracing. طيب, this system is good enough if we are having forces applied in this direction. What if you have wind applied in the other direction? Then you have to provide another bracing exactly identical. Exactly identical, like this. And I should indicate the vertical bracing and the vertical bracing and the vertical bracing. Very good. Now, this bracing is supposed to resist the wind loads blowing on this side, and this bracing is supposed to resist the wind loads blowing on this side. What if the wind is applied in this direction? If the wind is applied in this direction, it will be supported by the main system itself because it is parallel to the main system, which is a 2-dimensional system. One last thing. If the spacing between this bracing and the one that followed it is more than 40 meters, it is a common practice that we have to provide another one in the middle. We don't like the spacing between the bracing and this bracing to exceed 40 meters. What we have is 47. This distance is 47. So it is a little bit exceeding. So we need to put another one in the middle. But we don't have middle because the number here of spaces 1, 2, 3, 4, 5, 6, 7, 8. It is even number, no problem. The central line is here. Okay? We can either put our bracing on this in this bay or in that bay. It doesn't make a difference. We don't repeat them. Not necessary to be symmetric. For example, I will locate it here with the same arrangement exactly like the other bracing. And I will have, whenever we draw the horizontal bracing, we have to indicate the vertical bracing. This is a good plan that is showing us the columns. Write with me, please. The columns, the main system, the purlins, and the horizontal bracing, and the indication of the vertical bracing. One thing remains. Again, if we look to this view here, imagine that this is a frame. This is a frame like that. How are we going to cover the roof? We are having purlins, and these purlins are supporting corrugated sheet in this direction. How are we going to cover the side? As we said before, that we are having this part will be covered with brick wall, and if this is 3 meters and this is 7 meters, we need to cover this part, the 7 meter, with corrugated sheet. So what are we going to do? We are going to put a purlin here and a purlin just over the brick wall. The spacing between the purlins should be from 1 to 2. So I'm going to divide this into 4 equal spaces. Each spacing is 1.75. And I'm going to continue the corrugated sheet in this direction. We are having corrugated sheet like this, and we are having corrugated sheet like that. Question: what is the span of the purlin? The purlin is rested here and rested there. The span of the purlin is 6 meters. Imagine that we are having here, this is for example 24 meters, and we are having a frame like this. And I want to cover the front or the end gable. What am I going to do? I cannot have a purlin like this. The span of the purlin will be 24 meters. The cross section of the purlin will be uneconomic. What do? I'm going to have a column like this and a column like that will break this span. Instead of being 24, the spacing between the columns is ranging from 4 to 7 meters again. I'm going to locate these columns. These are called end gable columns. Why do we use the end gable columns? To break the span of the side purlin that will cover the facade. Therefore I will put here these purlins like this, and I will start covering the cladding like that, and this part will be covered with brick wall similar to the side, and this part will be covered with brick wall, and here we are having a door opening. Question: what is the function then of the column? Now the function of the end gable column is to resist the wind that is blowing in this direction. Whenever we are drawing this column, take care. The orientation of this column will be different. This column will be oriented in this direction. Because the wind, when it is blowing in this direction like that, it is causing moment about the strong x-axis. But if you located the column in this direction, the end gable column in this direction, and the wind is blowing perpendicular to the plane of the frame, then you are causing moment about the weaker y-axis. The end gable columns, especially, they are rotated. They are not in the same direction of the columns of the frame, they are facing the wind, because the function of this column and the function of this column is to support the cladding and also to resist the applied wind loads perpendicular to the facade. يبقى we need to locate the end gable columns. Again, the spacing between the end gable columns, as we said, is ranging from 4 to 7 meters. And of course, we have to respect, if we are having any kind of architectural design, I will locate a column left and right of the door. يبقى I will come here and maybe we can put one column in the middle. See بقى, the orientation of the column of the main system is with the main system, as we said, but the orientation of the column of the end gable is facing the wind. Okay? يبقى this span here is 6 meters. This distance here is 6 meters. Okay? Here we are having 24, so we can have a column here, and a column there. These columns are called the end gable columns. And also the same thing you will have on the other side. يبقى this is a complete plan. If you would like to provide axes, any column that is constructed usually is associated with an axis in our drawing, so we can put here this is axis 1, 2, 3, 4 up till 9, so this can be axis A, B, C, D, E, F, and G. Okay? And of course you have to give the spacing. This is 6 by 6 equals 36 meters. Okay? Of course we don't have end gable columns in the middle. The end gable column is only on axis 1 and on axis 9. In the middle, all of this area is void. We don't have any columns inside, and all of this part is void. We don't have any columns inside. So this is a complete plan of the roof. Just remind yourself what are the elements that should be drawn in the plan. We indicated the columns of the main system itself, the purlins, the end gable column, the horizontal bracing, and the indication of the vertical bracing. We gave the axes, we gave the dimensions, nothing is missing. This figure is taking 100% the full mark. Okay. Now, if we are having a truss, like that, and this was our truss that we drew together. And we said here that we are having purlins every 2 meters. And here we are having purlins every 2 meters. And here we are having the brick wall or the masonry wall, and here we are having the side purlins and then the rain gutter. Okay? At this level, at the top level, we have the upper wind bracing that is drawn here. And also at this level, we should have the lower wind bracing. But take care, the joints now are spaced at a distance of 4 meters. These joints are spaced at a distance of 2 meters. So if I want to draw the plan of the lower wind bracing, the plan would be something like this. These are the columns. And as if I am taking a section here in this direction at the bottom fibers, we are no longer having purlins, but we are having struts though. These are called struts. These are called struts, but these are purlins. Now I want to form a stable truss. It should be composed of triangles, and the angle should be ranging from 30 to 60 degrees. I know that this distance is 4 meters, and this distance is 6 meters, so I can take a cross like that. And of course, whenever you are having upper bracing, there should be lower bracing. Here I'm having lower, here I'm having lower, and here I'm having lower. يبقى also here I will have lower bracing, and here I will have also lower bracing. Whenever we are having lower or upper bracing, there should be an indication for the vertical bracing. We should show the instructor that we understand whenever we are having horizontal bracing, it will transfer the force to a vertical bracing, and this is the indication of the vertical bracing. It doesn't matter whether you draw this dotted line to the right of the central line or to the left. It doesn't matter because it's just an indication. Okay? So it is just an indication of the existence of the vertical bracing. There remains the columns, because we are having here the end gable columns. They are connected at the end gable columns are connected every 6 meters. That's not possible. Let me rearrange this again, please. Whenever we locate the end gable columns, they should be located at these joints because the column will not continue to the top. Okay? So I can have the spacing between the end gable columns either 4 meters or 8 meters. So we can have 8 and 8 and 8. So we can have here the location. Let me remove this. And we will have an end gable column here and end gable column there. So this will be D and this is E. And the spacing here this will be 2 by 6 and this will be 3 by 8 meters. Okay? Also the end gable columns, here I will have a column here and I will have a column there. Like this. يبقى the spacing here between the columns will be 6 meters, 6 meters, 8 meters, 8 meters, and 8 meters. Why did I do this change? Because whenever when we locate the end gable column, it is not correct that the end gable column will be here in the middle of the member. It will have to be located at the joint. So either that I will select an end gable column every joint, and this is so less, so I selected every other joint like that. So the end gable columns will be spaced at a distance of 8 and 8 and 8. These columns are oriented opposite to the orientation of the columns of the frame. That's why they are drawn in the plan in this way. Okay? So we are going to indicate this in the upper bracing. We are having a column here. In the lower bracing, I'm sorry. This is a complete plan of the lower wind bracing. Okay? This is the plan of the roof and the plan of the lower wind bracing. We have one more thing that I'm going to finish today, will be the mezzanine floor. Let me elaborate on this. The other side of the frame, if you recall, it was something like this. And here we were having a frame. This is the column pedestal, and this is the truss that we have. And we used here a rigid frame. This height, it was 10 meters. And we were having here purlins. Like this. And we had here purlins up till height 3 meters, and then we divided this into 4 equal spaces like that. And we are having here the rain gutter. Imagine that we want to have, this is 12 meters, and the slope here is 1 to 10. The spacing between the purlins is 1.5. Okay? Imagine in this part I want to make another floor. Okay? So we are going to have a beam, let us say at a height of 6 meters from there. Okay? And we are having this part, the remaining part is 4. And this will be 1.2. Because the distance is 12 and the slope is 1 to 10, this part should be 1.2. Now, we cannot have a floor as such. Why? Because when you are having any kind of loading, this beam will deflect like this. So in order to prevent deflection, you will have to enlarge the depth of the beam. When you enlarge the depth of the beam, you are reducing the clear height and you are making the structure more expensive. So probably the best thing is to provide a column in the middle. One student will tell me, well, you told us that it is not allowed to have any columns in the middle. Well, if I'm going to use this as a mezzanine floor composed of 2 floors, then I will have to provide a column in the middle better. And this area is the one that will be void from columns, and the columns will only be located at the boundaries of this area with a span of 12 meters. But here in this part, it is better to provide a column because this will reduce the span and will definitely make the structure more economic. Okay? But we are going to keep the roof as it is. We are not going to change the roof. Because as if you are taking a section here, so you are not going to see this column. Okay? Now, how is this system supported? We are having secondary beams located over the main beam, and then we are having a metal deck slab. So this is a metal deck slab. Thickness, for example, 10 centimeters. And here, these are the secondary beams. They are spaced at a distance of 2 meters. From the spacing here is ranging from 2 to 4 meters, the spacing of the secondary beam. And of course, this is the main beam that is rested directly on the column. How will this look like if I would like to take a plan in this direction? This is the plan of the mezzanine floor. How would this look like? Then this is our plan. Let me remove the 12. And in this plan, we will have a column in the middle because we are having this column here. Okay? And this is the main system. Okay, in this direction. We are having the spacing. This is 6 meters, 5 meters, and then 6 by 6 equals 36. We want to draw the secondary beams then. The secondary beams are located like that, in this direction. And we are going to locate on top of the secondary beams the metal deck slab. The metal deck slab is exactly like this. We are having, it is not corrugated sheet, it is metal deck. This is the metal deck. The corrugated sheet looks like this. See? There is a space between this wave and this wave in the corrugated sheet. So it is not suitable to cast concrete on top of it. If you cast concrete here, this part will bend like this. But here you can cast concrete on top of the metal deck slab because this spacing here is almost the same as that one. Okay? The thickness of the metal deck slab is ranging from 0.7 up till 1.2 millimeter. But the thickness of the corrugated sheet, this is the corrugated sheet, is ranging from 0.5 to 0.7 millimeter. So of course this is only suitable for the roof cover where nobody is going to use this roof. It is just a cladding. But here we want to cast concrete on top of it and people will be using this floor. Therefore we have to provide or to use the metal deck with another profile, as you can see. The direction of the metal deck will be in this direction. Okay? The waves of the metal deck will be perpendicular to the secondary beam. Again, before locating the metal deck and casting the concrete, we need a bracing system. Similar to the bracing system that we used here, the upper wind bracing, and it is associated with vertical bracing. There should be also horizontal bracing connected to the floor. How can I do this? We have this distance is exactly 6 meters. Therefore, we are going to select a bracing system like that. Okay, or this is 4 by no, I'm sorry. It is not really drawn with the correct scale. we are having this is 6 meters and this is 6 meters. They are supposed to be the same. Then the bracing can be like this. Okay, and of course we said that we are having a bracing also in the middle. And associated with the vertical bracing, there should be, with the horizontal bracing, there should be an indication for the vertical bracing. Again, this is just indication. It doesn't matter whether you draw it on this side or on that side. So this is our last plan. So we are having 3 plans. We are having the plan of the roof, we are having the plan of the mezzanine floor, and we are having the plan of the lower wind bracing, and we explained together the typical elevation, which was section A. There remains for us, if you are taking section here, or if you are taking section here in the beginning, so this is section B, how will the frame look like? Okay, I will erase this part. Okay, we are going to redraw exactly the typical elevation that we drew together. Last time. And we are having here the purlins. And here we are having the side purlins. And here we are having the rain gutter. Okay, and of course we are having, these are the column pedestal. This is the 0 level, and this level is plus 0.1. To close the facade, this will be section B that you will be required to draw as well. We will have to provide a column here with a column pedestal to reduce the span of the side purlins, and also we will provide a column here and a column here. Notice that the columns of the end gable, I did not show them to be touching the system itself because there is a deflection joint. What does this mean? It means that the truss can deflect without loading the column. Why did we do that? Because I don't want this column to support except the loads coming from the wind. I don't want the column to take any loads from the truss. Because if the column is supporting the truss, then the section of the column will be large. I want to put something so delicate that even when I remove this, the frame will stand still without any need for that column. This column is just located to support the purlins that will cover the facade. Now we will try to have the same levels of the purlins here. The purlins here are located at a distance of 1.75. So I will take the purlins like this. This part will be covered with brick wall, and this part will be covered with corrugated sheet. the corrugated sheet should be perpendicular to the purlins itself. And also here we have the columns provided, but it will be continued in this direction. And here I will have to provide extra beams or extra purlins to be rested on the truss itself if this distance is more than 2 meters. Then I will have to break it with another purlin like this. Okay. Of course I will have to provide door opening, so maybe we can remove these purlins and we can have door opening like that. And here we are having the cladding system, and here we are having the cladding system, and this part is covered with brick wall, and this part is covered with brick wall. Okay, so the thing that is new here, we have to provide the distance between all of the columns. This is 6 meters, 6, 8, 8, and 8. We have to provide the level of the brick wall. Okay, we have to provide the spacing between the purlins as we did before. Okay, and this will be section B. It is exactly like section A, except that we provided the end gable columns and the purlins in the sides. Okay, and I will continue with you another lecture where I'm going to elaborate on the side view and the transversal wind bracing. Thank you.